Question number 20, FRQ question number 25. The first question asks us to fill in the second box of this reaction equation, and the first box has 4H2O2, so we use this equation. 2H2O2 creates 2H2O plus O2, and if we multiply it all by 2 to get it to make it match this for strong, then we get 4H2O plus 2O2. The second question gives us a reaction graph, and we have to determine whether it's exothermic or endothermic. So we said it's exothermic because it's starting with more energy and it ends with less, so it has to be releasing this much energy into, like, the difference between these two into the surrounding system. Question number 3 asks if it's in the presence of this catalyst, what will the reaction graph look like now? And because it's with the catalyst, it'll require less activation energy, which means this initial hump will be smaller. So we do that. Question number 4 asks us to calculate the number of moles of oxygen gas produced in beaker 2. Beaker 1 is just a test, to compare and make sure it's accurate results. So because beaker 1 stays the same the whole time. So what we did is we took, since we have to calculate the moles of O2, we took the mass of beaker 2 at the beginning and subtracted it from the mass, or we subtracted the ending mass from the beginning mass to find the number of moles of O2, because in this picture we have the oxygen gas rising up and everything else is staying here, so the only change in weight would come from oxygen gas, like, dissipating into the air. So we find 0.61 grams when we subtract that of oxygen gas converted, and then we can divide that by the 32 gram molar mass of oxygen gas and find that there's 0.019 moles of oxygen created in this time period. Question 5 asks us to calculate the mass of H2O2 that decomposes during the 60-second period. So using the equation, we can see that there's a 2-to-1 ratio of H2O2 to O2. So we can multiply the amount of moles of O2 created by 2 to get 0.038 moles of H2O2 that were created. And then we can multiply that by the molar mass of H2O2 to find the amount of grams created, which is just like stoichiometry. The student then continues for question 6. It's asking, if you continue the reaction for another minute, will the reaction continue at the same rate? So because as the H2O2 is consumed and used up and turned into O2, the concentration value will lower, and this means that the reaction will proceed at a slower rate. Question 7 asks if it was some student claims that it's a 0th order reaction, but we didn't think that's true because the concentration is going down, the reaction will occur at a slower rate, and that wouldn't happen if it was a 0th order. The 8th question asks, a student did it. Basically in this question, a student did something, and as a result, the mass measurements that they got are not accurate. So because we use those mass measurements here, of the mass of the beaker to calculate the amount of O2, that loss means that the results created are actually not accurate. So it would distort the results. And then the last question just it gives us the reaction equation, and it just asks us to balance it. So we just balance the equation. So, all right.